asking us to find the derivative. So if you need your card, use it, but here's a reminder. E to the u is basically that itself times the derivative of the power. Okay, so let's go ahead and circle that power as a reminder. So we have y prime, copy as it is. And because I know I have to find the derivative and I'm going to leave it as a power rule, why not rewrite it as 1/2 power? Everyone should be writing. So when I derive this, isn't this basically a chain rule? Yeah? Bring the half down, keep the inside, 1 less is negative 1/2, and then we derive the inside. What is the derivative of the inside? What's the derivative of x?
1.
1. And that's it. You don't need to simplify or any of that. All right, our next one was number 11. Okay, on number 11, for any of the infinite limits, you can use the high over low, low over high in the same coefficient game. But if you forget, what was that rule that we talked about? L'Hopital's rule. Very good. So I'm going to use it that way, but let's do our anticipation real quick. Assuming you don't want to use L'Hopital's rule, let's see what we would get. If I have, in this case, is this high over low or low over high? So we know that 0 equals y. That's our anticipation. And that is our answer. But let's say you forget that rule on the infinite limits. You'll first plug in the infinity. And when I do, it's going to give you infinity over the infinity. And keep in mind, the rule for the L'Hopital's rule was, if it is 0 over 0 or infinity over infinity, you can use that rule. So I have L'Hopital's rule, the limit as x approaches the infinity. What is the derivative of my numerator right now?
6x.
6x. My denominator is how many?
12x.
12x squared. And I know we have our plus 6, which in the end is going to be irrelevant. And then when I plug the infinity again, that's still going to give me infinity over infinity. So that means I need to use L'Hopital's rule one more time. Oop. So when I do, I get limit as x approaches the infinity of, this person's not here. Can I give this back to you? Yeah. What's the derivative of 6x? What about the denominator? 24x. So then when I plug it in, we have some number over infinity. And we know as the number gets bigger and bigger and bigger on the bottom, it's going to reach 0. So again, if you're okay with the infinite limit from last year, keep it. If you want to use the L'Hopital's rule, that's going to work out every time in these two cases, keep it as well. Yes, sir?
Do you have to write the LHR in front of it every time?
It's a way to communicate to me that I realize I can use it. So I prefer it, okay, but I can't take off for it. Okay? All right, number 14. And then after this problem, or maybe I can tell you what you need to actually memorize. Okay, the things that you need to memorize, that's going to be a matching on the test. Y'all ready? Okay, this right here, make sure you have them memorized. And then I know we have the inverse derivative. I think it's the back of this. Should also be memorized. So if you need to take a picture, here I go. This should already be on a flashcard because I'm not going to keep giving this flashcard from the beginning every single time. All right, and I'm going to go to the front. So make them. And memorizing these 5 will be easy points. And not only that, you'll be using them throughout the test. So might as well. All right, so let's go ahead and look at number 14. On number 14, Cody, go ahead and read that one for me, please.
Given that f of x and g of x are inverses of each other, if g of 2 equals 7 and f prime of 7 equals negative 1/4, and g prime of 2 equals 20.
So I'm going to go ahead and use this right here. So plugging in 2 into the x, we have g prime of 2 is equal to 1 all over f prime of g of 2. So that was just plugging things in. And then what I would do from here is starting with the very, very inside. Do we know what g of 2 is going to be represented by?
Yes.
What number?
7.
So I have 1 over f prime of 7 Do we know what the f prime of 7 is going to be represented by? Yep, which is negative 1/4. And we don't want a fraction over a fraction. So let's multiply by the reciprocal, and when I do, I get negative 4. Questions on this one?